Hello guys, welcome to Step Ahead, and today we are going to discuss a very important concept through jailer problem. So what is a jailer problem? So in a city there is a jail in which there are 100 cells, and cells are numbered from 1 to 100. They are numbered from 1 to 100, 1, 2, 3 till 100. One day jailer is drunk, and what he do is that he alternatively opens and closes the cell of the jail, but he follows a particular order. What he do is that initially he goes to first, second, third. In first round, he goes to first, second, third, fourth, fifth till 100. In second round, he goes to second, fourth, sixth, eighth till 100. In third round, he goes to third, sixth, ninth, 12th, and so on. In fourth round, he goes to fourth, eighth, 12th, and so on. Similarly, in nth round, he goes to n, 2n, 3n, and so on. And he do it till he reaches the number 100. You can say till he does an 100 rounds. And in the last round, he will only go to the last cell, 100th cell. So what he do is that every time he reaches a particular cell, if the cell is closed, he opens it, and if the cell is open, he closes it. So you have to tell, after jailer completes its 100th round, how many of the cells will be open. Let me discuss it with a small example. Suppose there are 5 cells. Or let it be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let there be 8 cells, let us suppose. And initially all cells are closed. So in first round he opens this, opens this. In second round he closes this, he closes this, and he closes this. Similarly in third round he closes this, he opens this, 3, 6, and in fourth round he opens this, he opens this. In the fifth round he closes. In the sixth round he closes this door. In seventh round it is open, he will close it. In the eighth he will close it. So let us see how many doors are open. So this is closed, this is closed, this is closed, this is closed, this is open, this is closed, this is closed, and this is open. So only 2 cells are open, first and fourth. So think about this problem, take some time, and come back to see the solution. So now let us discuss the solution. Now let us think how many times jailer will be able to reach a particular cell. So it can be clearly seen that let this cell be any number, let it be 24. So he will be able to reach it in first round, in second round, in third round, in fourth round, in sixth round, in eighth round, in 12th round, and in 24th round. How can I say this? I can say this because we can clearly see that the jailer is following an AP, right? And if a number divides this number, he will able to reach that cell because it will be able to, because we know that Tn is equal to A plus n minus 1 into D, right? So we know that A and D are same in this case because if it starts from 4, like if it starts from 4 it will go 8, 12. The difference is 4 and the first term is 4. Similar, so we can, so A plus n minus 1 A, which is equal to A 1 plus n minus 1, taking A common, which is equal to A into n. So Tn will be clearly a multiple of A. N can be any number and it will be multiple of A, right? So we can prove that any term will be multiple of A. So 24, the numbers which divide 24 will be eventually able to reach this cell. If jailer starts from a number which divides this, so jailer will be able to reach 24. I hope you have got this concept. Now we will use this concept of devices or devices exist in pairs. What does this mean? So 24 is equal to 1 into 24 or 2 into 12, 3 into 8, 4 into 6, and then the numbers will repeat. Okay, so we can clearly see that as we can write 24 as a product of two numbers, so divisors exist in pairs because if we divide it with 6 we will get 4, and if we will divide it with 4 we will get 6. So divisors exist in pairs, right? So 24 has how many divisors? 1, 2, 3, 4, 6, 8, 12, 24. Similarly, taking another number like 42. So 42 can be written as 1 into 42, 2 into 21, 3 into 14. It is not divisible by 4, it is not divisible by 5, it is not divisible by, it is divisible by 6. 6 into 7 and number ends. So 42 has 1, 2, 3, 6, 7, 14, 21, 42. So numbers exist in pairs 6, 7, 3, 14, 2, 21, 142. Another thing to notice is that they are symmetric with respect to center, or you can say square root. So square root of 42 is somewhere between 6 and 7. So it is symmetric about the square root line. You can see that. Same is the case with 24. So 24 we can do it above only. So the square root of 24 lies between 4 and 5. So square root will lie somewhere here, and you can see that it is symmetric about this position. You can say about center or about square root line, right? Now coming to the problem, and one more thing I want to tell you is that is the core main part of the solution, that if a number is perfect square, it has odd divisors. Why? Let us take some perfect square, for example 49. So dividing it 1 into 49, and then comes 7 into 7. So why is it so? So it is a so because if it is a perfect square, its divisor will be repeating. You can see that 7 is repeating twice. Let me take another example of 16. 1 into 16, 2 into 8, 4 into 4. You can see that divisor is repeating. So in the end, eventually for 49, let us take, it will be 1, 7 and 49. For 16, it will be 1, 2, 4, 8, 16. And one more thing is that square root passes through the center. For example, the square root of 49 is 7. As it is a perfect square, so it will pass through the center. And as I said that it is symmetric about center, so it is symmetric in this case also. Taking the square root of 4, it passes through this, and it is symmetric. And if it is symmetric, you can see that all others pair other than 4 will exist in pair. So so the divisors will be of the form 2n plus 1. 1 is because square root is exactly at center, at a number. Square root lies at the number, or you can say a divisor, because it is repeating, right? 7 into 7, 4 into 4, 8 into 8. You can take any number. So the final conclusion is, you must remember this, as it will also help in solving and optimizing a lot of questions which we will discuss in the further videos. So the final conclusion is, first, if number is not a perfect square, which means its root has decimal representation dot something, then its divisors are even. Second point, if number is perfect square, then divisors are odd in number. A perfect square is 1, 4, 9, 16, 25, and so on. And so on. Okay. Do remember this. It's an important property. Now, coming to the solution. So, now let us consider 24 or any even cell number. Or let us take any cell number which is not a perfect square. So, let us take any cell number which is not a perfect square. So, let me draw a line in center which denotes its square root, right? And now let me represent its divisors. So its divisor, let it be A1, A2, A3, A4, AN. So as there are n divisors in left side, there will be n divisors right side, right? B1, B2, B1, B2, B3 till Bn, right? And divisors in right hand side. So now let us do the calculation. Okay. So GLF first opens it, then closes it, then opens it, then closes it. Similarly, when it will reach here, have you got the clear idea that if they are even in number, eventually in the end the jail will get closed, because how many times it is opened, it will be closed that many times only, because it is even in number. Like it is open, suppose like this is the, I can't generalize. Let us take an example, like let us take an example of letter 22, right? It's more, it devices are, let us take some big 26. So it will be 1 into 26, 2 into 13, and that's all, I think. Yes, there are no more devices. So if this is the square root line, 1, 2 will lie here, 13, 26 will lie here. Okay, so it gets opened, it get cancelled by this, and open, close, open, close, right? It gets opened, and it gets opened, and it gets cutted by this, it gets cutted by this. Let me take some another example. If I hope you have got the clear idea what I want to say. Let me take last example of which has a lot more devices. Let us take 46. I hope it has more devices. 1 into 46, 2 into 23. I think it doesn't have any more. Let us check 24 only. 1 into 24, 2 into 12, 3 into 8, 4 into 6. So this is the square root line. 1, 2, 3, 4. 1, 2, 3, 4, and 6, 8, 12, 24. So it gets opened, closed, open, closed, open, closed, open, closed. Because eventually, if it gets opened at 1, it will get closed at 24. If it gets open at closed at 2, it will get open at 12 at their consecutive pairs. Reverse task happens at their consecutive task. You can see that. If at pairs, opposite thing happens, right? So, and that is the note case with if a number is if the cell is perfect square. Let me take an example of 49, or let's say 36. So it's 1 into 36, 2 into 13, 2 into 18, 3 into 12, 4 into 9, and eventually 6 into 6. So 6 it is at center. 1, 2, 3, 4, 9, 12, 18, 36. So if it gets opened here, it gets closed, it gets opened, it gets closed, it gets opened, it gets closed, it gets open, it gets closed, it gets open. So you can see that if the number is odd, it will get opened, which is true also. So eventually in the end, those cells will be opened which are perfect square. So our final answer will be 1, 4, 9, 16, 25, 36, 49, 81 and 100, which are equal to 10. So our answer is that in the end only 10 cells only 10 cells will be open. Thank you for watching this video. I hope you enjoyed with this video, and if you have any doubts or any suggestions, you can comment below in the video. Thank you.